So for this problem, what I'm seeing is I'm seeing that they told me a mean. They're telling me the mean of this population is 18 weeks, and that's the standard deviation for the population. So I know I'm dealing with sample means, a distribution of means. Well, not yet. First off, I'm talking about a single mean. So because this is just a single mean, this is basic normal distributions. We just got to make sure the mean is 18 and the standard deviation for the population is 2.6, and they want to know what's the probability of getting an average number of weeks of a single individual's unemployed is greater than 18.3. And we're going to calculate that, and that's almost half. And of course, that would make sense since the mean is 18. Now we're into sampling distribution territory, and as we know that when you're dealing with a sampling distribution, the central limit theorem says to find the standard deviation for all those sample means, you can take the population standard deviation and divide it by the square root of the sample size, because as you get a larger and larger sample, there's less variation in how all those samples will behave. So I'm going to use my calculator here on screen to do this calculation. So 2.6 divided by the square root of 71. That's my standard deviation for this sampling distribution. We know the mean is the same as the population mean, so the mean of all the samples of the same size, in this case 21 or 71, will be the mean of the population, which is 18, and then the standard deviation is a little bit smaller than the population. Actually, it's quite a bit smaller, isn't it? Let's see, how many decimal places do I want to do? I guess I'll go with that. And again, we want above 18.3, so let's recalculate it. The alpha is telling me a little bit more than 16%, and the answer in my open maths is saying a little bit more than 16%. I mean, if we're going to do this with your graphing calculator, you can do second bars 2, because it is a normal CDF problem. The bottom of this shaded area is 18.3. And the upper part, we're just going to put some ridiculously high number to, so we're way past what it could be. And then we're going to do the mean of 18. And for the first one, since we're dealing with a single individual, we're just going to type in the standard deviation of 2.6. And that agrees with what I got with the applet and with the answer. Then we're going to divide that standard deviation by the square root of 71. And notice that's the same as that. Okay, just in case you didn't see that, if you do second enter, it'll dump the last thing you just calculated or entered in your calculator right there. Second answer gets the last calculated answer. Okay, so I hope this helps you answer this question.